Okay, so today we are doing finding zeros and possible zeros of polynomials. But before we get started on that, let's do a little review of long division. Okay. So for our first example for long division review, let's say I had 2x to the fourth plus 5x cubed plus 7x squared plus 16x plus 6 divided by 2x plus 3. Okay, so we're just going to do a little bit of long division here. So again, what we're dividing by goes on the outside. So 2x plus 3, and then we draw our little box here and put this first polynomial on the inside of that box. So 2x to the fourth plus 5x cubed plus 7x squared plus 16 plus 6, okay? And then we are just focused on this 2x, and we start by focusing on 2x to the fourth. So what could I multiply by 2x to get 2x to the fourth? Well, that would be x cubed, so I'm going to put that above my x cubed term. And then we're just multiplying x cubed to both of these terms and putting them under the appropriate variables. So x cubed times 2x squared would be 2x to the fourth. X cubed times 3 would be plus 3x cubed. And then remember, we're subtracting this. So this becomes negative, and then also this sign right here becomes negative. So that would be a 0. That's what we wanted. And then we have 5x cubed minus 3x cubed, or this should be a 3x cubed. So that would be 2x cubed, and then we drop down this plus 7x squared. Okay, and then we're doing the same process again. What can I multiply by 2x to get 2x cubed? Well, that would be x squared, positive x squared. Okay, and then we're multiplying. So x squared times 2x would be 2x cubed, and then x squared times 3 is plus 3x squared. And then again, we're subtracting this. So this becomes negative, this becomes negative. That's 0. 7x squared minus 3x squared is 4x squared. And then we drop down this 16. What can I multiply by 2x to get 4x squared? That would be positive 2x. And then we multiply 2x times 2x, 4x squared, 2x times 3. Oh, I'm sorry, this should have an x. I'm just making mistakes left and right. Okay, there we go. That looks better. 2x times 3 is plus 6x. And then again, we're subtracting this, so we're changing the signs. So that's 0, and then 16x minus 6x is 10x. And then I drop down the 6. And then I want to know, what can I multiply by 2x to get 10x? That would just be a 5. And then 5 times 2x is 10x. 5 times 3 is, have I done something wrong? I did, you guys, I did something wrong again. I'm so sorry. This should be a plus 15. I don't know why that was a 6, but I'm so sorry. So that should be plus 15, and then we drop down this plus 15. My bad. So then we're taking this 5 times this 3 to get 15 again. There, this is going to work out much better now. And then we're subtracting this, and then we get 0 and 0. So my final answer is this up here. Okay, so that would be my polynomial final answer. So let's do another example, since that one just did not go the greatest. Let's do x to the fourth plus 4x squared plus 5x minus 5 divided by x minus 3, okay? So again, I put my x minus 3 on the outside, and then divided by, so this would be x to the 4th. So we don't have an x cubed term here, so remember we have to put a placeholder. So we're going to put plus 0x cubed plus 4x squared plus 5x minus 5, okay? And then I want to know, what can I multiply by x to get x to the 4th? That would be x cubed. X cubed times x is x to the 4th. X cubed times negative 3 is negative 3x cubed. Okay, and then we're subtracting this. The sign changes, so now we're adding here. That's 0, and then that's positive 3x cubed. And then I drop down 4x squared. What can I multiply by x to get 3x cubed? That would be plus 3x squared. And then I multiply. 3x squared times x is 3x cubed. 3x squared times negative 3 is negative 9x squared. And then we're subtracting that, so this becomes addition. That's 0, and then that would be 13x squared. And we're dropping down this 5x. What can I multiply by x to get 13x squared? That would be plus 13x. And then I multiply, so 13x squared minus 39x. Okay, and then we're subtracting, so that becomes negative, this becomes positive. That's 0, and then we get 44x. Drop down the negative 5, 44x minus 5. What can I multiply by x to get 44x? That would be plus 44. Then we multiply. And then we're subtracting these, so this becomes a positive. That's 0, and then we get a remainder of 125. So remember, how we would write that is plus 125 divided by whatever we were dividing by. So divided by x minus 3. And that would be our final answer right there. So it's kind of ugly since we had a remainder, but that would be our final answer. Okay. Okay, now let's get into some new stuff. So let's recall when we find factors. When we find factors of a polynomial, so basically when we're solving for x for a polynomial, we are finding zeros or x-intercepts on a graph. So we talked about this in class, but for example, if I had f of x is equal to x squared plus 7x plus 12, and I factor that to look like f of x is equal to x plus 3 times x plus 4, well, that would give me two solutions for x. I'd get x is equal to negative 3 and x is equal to negative 4. Well, on a graph, obviously this is a parabola, right? So on a graph, my zeros, my x-intercepts, would be at negative 3, 1, 2, 3, and negative 4. And so my parabola would look something like this. Okay. Okay, so let's do an example, and then we are going to learn a theorem today. So let's say I had the polynomial f of x is equal to x cubed plus 2x squared minus 11x minus 12. Well, we talked about that since the degree of this polynomial is 3, we have 3 solutions for x. So that's basically what we're going to call the fundamental theorem of algebra. okay? So that says that this polynomial, the example above, has 3 solutions, the same number as the degree. But like we did before, some solutions are real and some are imaginary. So this doesn't necessarily mean that it has 3 x-intercepts, but some real and some imaginary solutions. It could have all real, it could have some imaginary, some real. Okay, we don't necessarily know. Okay, another kind of definition that we are going to talk about here is possible zeros. So these are possible x-intercepts. This is just how you find what your options are. So in general, possible zeros can be defined as factors of the constant divided by factors of the leading coefficient. Okay, this is something that I feel like students forget a lot, so make sure that you highlight this, you remember this, that to find the possible zeros, you have to take the factors of the constant, whatever the constant number is, divided by the factors of the leading coefficient. So, for example, for number 1, my constant is 12, and the factors of 12 would be 1, 12, negative 1, negative 12, 2, 6, negative 2, negative 6, 3, 4, negative 3, negative 4. So those are the factors of my constant divided by the factors of my leading coefficient. Well, this is nice because my leading coefficient here is just 1, and the factors of 1 would just be positive 1 and negative 1. So this is a pain in the butt, but we're going to take each of these numbers divided by each of these factors of the leading coefficient. So 1 divided by 1, 12 divided by 1, negative 1 divided by 1, negative 12 divided by 1, 2 divided by 1, 6 divided by 1, negative 2 divided by 1. And then we're going to do the same thing, but with negative 1. So 1 divided by negative 1, 12 divided by negative 1, negative 1 divided by negative 1, negative 12 divided by negative 1, 2 divided by negative 1, and so on. So it is kind of a pain in the butt, but you'll see that there's a lot of overlapping numbers here. Okay, so let's list out our possible zeros. So again, I'm just going to start with 1. I'm going to do all these numbers divided by 1, which would just be themselves, right? So I have 1, 12, negative 1, negative 12, 2, 6, negative 2, negative 6, 3, 4, negative 3, negative 4. And actually, you could write that as plus or minus 1, plus or minus 12, plus or minus 2, plus or minus 6, plus or minus, oh, I wrote a 3 when I meant a 6, but 3 is also a possible zero, but plus or minus 3, plus or minus 4. And then also notice that when we divide all of these numbers by negative 1, we're actually still getting all of these same numbers. They're just duplicates. So this list right here are the possible zeros for this polynomial, okay? We don't know which ones it is yet, but we know that these are our possible solutions. And how we find which numbers are actual zeros, we have to use guess and check using synthetic division. Okay, so normally if we were in class, I would have us guess and check a lot of these numbers, but since I'm just giving you the notes today, this is actually going to be a lot quicker. So let's set up synthetic division. Okay, and how we know that one of these possible zeros is an actual zero is if our remainder is 0. That's what we want. We want a remainder of 0. So normally you would just start plugging in some of these numbers. So you could plug in +1, you could plug in -1, you could plug in +12 or -12, but you're just plugging in these numbers until you get a remainder of 0. Let's try -1. So drop down the 1, adding +12. Okay, -12 times +12 is 0. We draw a little smiley face there because that's what we want. We want our remainder to be 0. So that means one of my solutions is x is equal to -1. Because when I did synthetic division with -1, I got a remainder of 0. Okay, so from here, these numbers give us the coefficients for another polynomial. So we start with x to the 0, x to the first, and x squared. And now I can rewrite this as a quadratic with these numbers as my coefficients for these variables. So what this quadratic looks like now is 1x squared plus 1x minus 12, okay? And then from here, we can factor and get our other two zeros. So what this would look like factored is x plus 4 times x minus 3. And then from here, we get our other two zeros for x, -4 and +3. Okay, so all of these solutions were real, but we got our 3 answers for x here. Okay, so it's kind of a pain, and it's going to take longer when you do it yourself because I know the right answers already, but you're gonna have to guess and check some of these. Okay, all right, let's keep going. We have 1, 2, 3 more examples here. Okay, let's say f of x is equal to x cubed minus 4x squared minus 11x plus 30. Okay, and I want to know what are the solutions to this polynomial. Okay, you can't factor this one, so this is where we have to find the possible zeros and use synthetic division. So first let's find the possible zeros. So remember, possible zeros are factors of our constant. So in this case, my constant is 30. So let's list out the possible zeros for 30. Plus or minus 1, plus or minus 30. I might need more space. Let's actually move this down here. Okay, plus or minus 30, plus or minus 2, plus or minus 15, plus or minus 10, plus or minus 3, and then plus or minus 5, and plus or minus 6, divided by the factors of my constant. Well, my constant here is just 1, so that's plus or minus 1. So since my constant here is just 1, basically, these are all of my possible zeros. So let's set up synthetic division. And then my coefficients are 1, -4, -11, and 30. So again, you would have to use guess and check on this one and just start plugging in some of these numbers in for synthetic division until you get a remainder of 0. So you could plug in +1 there, -1 there. You could plug in 30, -30, 2, -2, anything like that, okay? But I know the answer, so let's try 2. And let's use synthetic division. Okay, so we got a remainder of 0. This is what we want. So one of my solutions is x is equal to 2. Now I turn this into a quadratic. So we start with x to the 0, work our way up. And this becomes x squared minus 2x minus 15. And then I can factor this. So to factor this, it would be x minus 5 times x plus 3. And then I get 2 other solutions for x from that. So if this was equal to 0, x would have to be positive 5 and x would have to be negative 3. And these are my 3 solutions here. Okay. Next one. So this one actually gives you, so we're going to say given f of -6 is equal to 0. So that tells us one of our solutions already, because this is saying when I plug in -6 for x, I get out 0. So one of my solutions I already know is x is equal to -6. So really, we're just finding our other 2 solutions for x. Let's still list out our possible zeros. So factors of the constant, which in this case is -24. So plus or minus 1, plus or minus 24, plus or minus 2, plus or minus 12, plus or minus 3, plus or minus 8, plus or minus 4, plus or minus 6, divided by the value of, or the factors of my leading coefficient, which is 3. So plus or minus 1 and plus or minus 3. So if I divided all of these numbers by plus or minus 1, I would still get these numbers. But now our possible zeros are also all of these numbers divided by 3. So some example of what that would look like would be plus or minus 1/3. Plus or minus, well, 24 divided by 3 is 8, which we already have that. So plus or minus 2/3. 12 divided by 3 is 4, so we already have that. 3 divided by 3 is 1, we already have that. But plus or minus 8/3. Plus or minus 4/3. And then 6 divided by 3 is 2, so we already have that. So our possible zeros are now all of these numbers plus all of these, because we have this other number in our denominator, okay? But since we're already given that -6 is one of our solutions, that helps us out a lot, which means we're just going to plug -6 into our synthetic division to start. So when we do this, we know we're going to get a remainder of 0 for sure. And yep, we did. 0. And now we can write this as a quadratic. So x to the 0, x to the first, x squared. So this looks like 3x squared minus 4x minus 4. Okay, we want to factor this. This is a guess and check problem. So how this factors is 3x plus 2 times x minus 2. Well, like I said, we already know one of our answers is x is equal to -6. This factor right here tells us that x has to be positive 2. And then this other one, if we set it equal to 0 and solve, my other solution is that x is equal to -2/3, which again, we saw that in our possible solutions over here, okay? So these are my 3 answers for x. Okay? Okay, last example here. So there's our polynomial. Again, I'm going to give you a solution. So given f of negative 3 is equal to 0. So that tells us one of my solutions for x is already negative 3. Let's still find our possible zeros. So the factors of our constant, which in this case my constant is 9, so that would be plus or minus 1, plus or minus 9, and plus or minus 3, divided by the factors of my leading coefficient. My leading coefficient is 2, so this would be plus or minus 1, plus or minus 2. For fun, let's just go ahead and list out all of these numbers. So I'm going to take all of these divided by plus or minus 1. So that would be plus or minus 1, plus or minus 9, and plus or minus 3. Now I'm going to take all of these numbers divided by plus or minus 2. So that would be plus or minus 1/2, plus or minus 9 over 2, and plus or minus 3 over 2. So those are all of my possible zeros. But we don't really have to worry about guess or check here, guess and check, because we already know negative 3 is one of my zeros. So let's do synthetic division. And then turn this into a quadratic. So that's 2x squared plus 5x plus 3. Again, to factor this is a guess and check problem, and this factors to 2x plus 3 times x plus 1. So again, we already know one of our solutions is x is equal to negative 3. This factor right here tells me that x has to be negative 1. And then when I set 2x plus 3 equal to 0 and solve for x, we get x is equal to negative 3 over 2. Okay? And these are all 3 of my solutions for x.